All right, today's learning target is that we're going to look to solve systems of equations like we did in the previous lesson, except today it's going to be with 3 variables instead of 2. This first problem is a word problem, and it says, at the 2004 Summer Olympics in Athens, Greece, the United States won 103 medals. They won 6 more gold medals than bronze and 10 more silver medals than bronze. Write a system of 3 linear equations that could be used to determine how many of each type of medal the U.S. Olympians won. And then it says let G be gold, S be for silver, and B for bronze. Okay, so if we're going to do this, we want to kind of read through each sentence and see if we can figure out something from that we can write as a math equation. The first one says there was a total of 103 medals. So that should mean if we add up each type, gold plus silver plus bronze, that there's going to be a total or equal 103. Okay, next, it says they won 6 more gold medals than bronze. Okay, so if we want to make those equal, gold medals and bronze medals, there's more golds than bronze, so if we want to make them equal, we need to add 6 to the bronze side, and then they're equal to each other. But then it goes on and says also 10 more silver medals than bronze. So if we want to make silver equal to bronze, there's more silver. So to make them equal, we should add 10 to the bronze sides to make them equal amount. Now we have 3 equations with 3 variables. We should be able to solve it like we did before. Now, when we did this before, we could do graphing. Graphing is not the easiest when you start getting into 3 variables. So we want to probably limit ourselves to either substitution method or elimination method. Because we got these 2 equations at the bottom where it's G equals and S equals, this looks like a good one to use substitution method, where we're going to substitute in each equation in for something else. So we can take what we know G is equal to and plug it into G, and we can take what S is equal to, substitute it in for S, and now we'd have one equation with only the B variable, which we should be able to solve. So let's make those substitutions to see what it looks like. We'd have B plus 6 plus B plus 10 plus that other B should be 103 metals. If we solve this out now, we should be able to do it. Now the parentheses are always where you start. However, we can't add those 2 together because one's a constant term, one's a variable term. And there's nothing outside those parentheses to multiply. So really the parentheses aren't doing anything useful in this problem. We can just go ahead and combine like terms. So it looks like we have a total of 3 B's plus, if we add these constant terms together, 6 and 10, that's going to be 16 equals 103. If we solve this out now, we should be able to find out how many bronze medals there are. If we subtract 16, that gives us 87, divide by 3, and that tells us there was 29 bronze medals won. Okay, to find out how many gold and silver now, the easiest thing to do would be to go back in and substitute those back in. And these 2 equations right here that we had kind of highlighted before would be the easiest ones to do, because we know there's 6 more golds than bronze. So golds, there's going to be 29 plus 6, which would be 35 golds. And using this last equation, we know that the number of silvers equals the number of bronze, which is 29 plus 10. So it looks like silver, there's 39. So now we know how many of each type. Okay, that's called a system of 3 equations. And when you can substitute, usually the problem isn't too bad. The tougher one comes when you get one like our next problem, where substitution is probably not a good idea, because here we don't have any x equals or y equals equation like we did in the last one. So how are we going to solve this one? Elimination, elimination, elimination. The hard part is to eliminate here, we need to get rid of one of the variables, and you can't always do it so easily. So what you want to try to do on these elimination ones with 3 equations is try to get the same number in front of um, all 3 variables where you can eliminate. Okay, so looking at these ones, like if we look at z, might not be a good choice here because you'd have to multiply all 3 equations by something. Looking at y, again, you'd have to multiply all 3 by something to make this the same number. It looks like x in this problem would be the best one because these two already have a 2 in front of it. We could just multiply the top one by 2 as well. Now they all have 2. And just like we did with elimination, we want one that has a different sign. So let's multiply the top one by a negative 2. That would make the top one have negative 2 and the other two have positive 2. So let's go ahead and multiply through there. You'd have negative 2x minus 4y minus 2z. Make sure you multiply the constant term at the end too. That would be negative 20. We're going to leave these other two the same. Okay. Now our goal is to eliminate down to 2 variables. And how we do this is we're going to add together the ones that would eliminate the x. So I'm going to label these as equation 1, equation 2, and equation 3. Okay? If we were to add together equation 1 and equation 2, we should get the x variable to eliminate. So let's add those together and see what we get. So adding those two together, the negative 2x and 2x cancel out. If we add these other ones together, we get negative 4y. This is like a negative 1y, so that's going to be negative 5y. If we add the z terms together, negative 2z and 3z, that's 1z, or just z. And then adding the two last constant terms together, negative 20 and negative 5 would be negative 25. Now we've eliminated the x. Okay, but this equation we just came up with, we still can't solve because there's 2 variables. So we need another equation that only has y and z in it. Okay, so we need to add together another 2. So if we add together equations 1 and equation 3, we should also get the x variable to eliminate. And we're going to get a different equation than what we got adding 1 and 2. So let's add the first and last equation together here. So again, x eliminates. If we add the y's, negative 4 and negative 3 is negative 7y. Adding the z's together, you'd also get negative 7z. And then adding the constant terms, you'd get 7. So now we've eliminated, and we have 2 equations, 2 variables. Well, this is something you guys should know how to do from the previous lesson. We just went through how to solve a 2 equation, 2 variable problem. So what we want to do now is, again, eliminate another variable. Looks like the easiest way we could do that on this one is to multiply the top equation by 7. If we were to do that, our z's should eliminate. So let's multiply through the top one by 7. We would get negative 35y plus 7z equals, if you take 7 times negative 25, that would be negative 175. The bottom equation, we're just going to leave how it was. Okay, so now we want to add these 2 equations up and see what we get when we do that. Adding the y's, you get negative 42y. The z's eliminate like we want. If we add those constant terms together, we get negative 168. Now we're finally down to an equation that we can solve. So if we divide by negative 42, it looks like the y in this problem ends up being 4. So y equals 4. Okay, that took us a while to get there. Unfortunately, we're not quite done with this problem. We still need to find what the other 2 variables are. But the good thing is all the heavy work is done. We just have to go back now and do some substitution. Now, we don't want to go all the way back up to the original problem quite yet. Because if we try substituting right now, we're still going to get stuck. We'd still get some equations that have 2 variables. We want to go back to where did we have just 2 variables. So we want to look at one of these equations right here to substitute back for, because these ones only have two variables. I think this top one right here would be a nice one to substitute. We should be able to find z if we plug 4 in for y. So right there, let's make that substitution. So we have the equation negative 5y plus 1z, or just z, equals negative 25. If we plug that 4 in that we just found out, substitute that in for y, now we can find out what z is. So adding 20 to both sides looks like z equals negative 5. So now we found 2 of the 3 variables. We got 1 left to do. So now is the point we want to go back all the way to the original problem and pick one of those equations on top and substitute it back in. We still need to find x. So if we substitute, let's go with the top equation right here. We got x plus 2. We found out that y was 4. And we just found out that z was negative 5. Solving that equation out, now we should get the answer. 2 times 4 is 8, plus negative 5 would be 3. And then subtracting 3 looks like x equals 7. So now we found all 3 variables, and that would be the answer. We can leave them all circled like that, or on these systems of 3 equations, you can also list your answer as what's called a ordered triple. So you can make an ordered pair that has all 3, or an ordered triple that has all 3. So we found that it was 7, 4, and negative 5. So you could also list your answer like that. Let's try another one. On this next one, we want to eliminate one of these variables here. So why don't you pause it, the video, see if you can try figuring out one variable that would be good to eliminate. All right. On this one, I would say probably the easiest one to do would be y's. If you picked something else, you definitely could do it, but y to me looks like the easiest because it'd be easy multiplication to make those all 2. Not that you couldn't do it with the other ones. So let's multiply the first equation and the bottom equation by 2. That makes them all 2. And we don't need to add in a negative. You could if you wanted, but we should have one equation here, the bottom one, that ends up being negative 2, and the top 2 being positive 2. So if we make those, or if we multiply those out, we get 6x plus 2y plus 2z. 0 times anything, still 0. The middle one we're leaving alone. And the bottom one we're going to multiply by 2, we get 8x minus 2y minus 6z equals 18. Okay, now we want to add these together. Why don't you pause the video, try adding these together quick. All right, let's see how you did adding them together. If we label these again as equation 1, 2, and 3 here, it looks like on this one we should be adding together equation 1 and 3 because that would eliminate y's. And also you'd want to add together equation 2 and 3. That would eliminate the y's as well. So if you add together the first and last equation, you get 14x minus 4z equals 18. If you add the middle and bottom one, you'd get 7x minus 8z equals 15. Now you got 2 equations, 2 variables. At this point, we should know how to solve the problem and go from there. You could do any type of multiplying you want, like you could multiply the top one by negative 2 to eliminate z. You could multiply the bottom one by negative 2 to eliminate x. I think I'm going to go with that. Then we can solve this one out. So let's multiply the bottom here, leave the top one alone. Okay, so if we add together, those x's eliminate like we want. We got 12z equals, if we add the constant terms together, that's negative 12. And so it looks like z ends up equaling negative 1. So now we found one of them. Why don't you pause the video, see if you can substitute back in now and find both y and x. All right, let's see how you did here. At this point, you'd want to substitute this back into one of the equations with two variables. I don't know, this one might be a good choice right here. Let's substitute in for that z. So you got 14x minus 4 times -1 equals 18. Multiply two negatives, that's going to be a positive. Subtract 4 and divide by 14, looks like x equals 1. Now we got to go all the way back up to one of the original problems and find out what y is going to be. I'm going to pick this top one right here. That looks like an easy one. So we got 3x is 1 plus y plus z we know is -1. If we multiply 3 and 1, we get 3. Added to -1 is 2. Minus 2 from both sides looks like y is -2. So we found now all three variables. If you want, again, you can list your answer as an ordered triple. It would be 1, -2, -1. Okay, that's called system of three equations. All right, let's look at a couple more here. On this next one, we have three equations. Now, if you're looking here, there doesn't appear to be any x, y, or z that looks really easy or jumps out as a quick one to do. If that's the case, one thing that might work out is if you see anything you can simplify by, meaning you can divide all the equations instead of multiplying by something, you can do that too. Like this top equation, all these numbers 4, 6, 4, and 12 are all divisible by 2. The middle equation 6, 9, 6, and 18, those numbers are all divisible by 3. The bottom equation doesn't have necessarily anything that divides into all those. So let's see if we can divide first, and maybe that'll make it easier on ourselves. So let's divide everything on the top equation by 2. You'd get 4 divided by 2 is 2. -6 divided by 2 is -3. And 12 divided by 2 is 6. The middle one, let's divide everything by 3. Okay, and we get these three equations out. Okay, so what we want to do is look to solve those. However, you should notice something now about these equations, especially the top two. These top two equations have the same x, y, and z values. Their constant terms are different, but the other ones are all the same. If you recall from yesterday, when you have things that are the same like that, what's that mean about the lines? It's not necessarily it's not going to be the same line here because these are different, but if the other stuff's the same, that's telling us that these lines are parallel. And if you have parallel lines, these three lines are not going to be able to cross at one location. So this one, we can see without even solving it, that since you have some parallel lines, this one's going to end up with no solution. Okay, so anytime you have equations that are the same that give you parallel lines, you will not be able to go through and solve and figure out an answer. Let's look at another one here. See if you can simplify these two equations on D first by doing some dividing. All right, let's see what you came up with. Looks like the top equation, everything there is divisible by, oh, nope, not, everything's divisible by 2. And it looks like the middle one, everything is divisible by 3. The bottom one, not able to divide by 2 because 7 is an odd number. So let's go through and divide. And you end up with this. The top two equations, again, you can see are the same stuff right here. That's telling us parallel again. this is going to be a no solution problem. So if you can see stuff like that, that saves you time rather than going all the way through and solving. You can always simplify out. All right, let's try a couple word problems. On this next one, it says the sum of three numbers is 20. The second number is 4 times the first, and the sum of the first and third is 8, right? And solve a system of linear equations. I want you to pause the video on this one. See if you can write out 3 equations, similar to what we did in that Olympics problem earlier, and see if you can get 3 equations. All right. Let's see what you got here. Some of you may have used different variables. I'm going to use x for the first number, y for the second number, z for the third number. If it says the sum of the 3 numbers is 20, we can say that x plus y plus z is going to be, all 3 numbers added is going to be 20. This next sentence says the second number is 4 times the first. So the second number y is equals 4 times our first number would be x. And then finally it says the sum of the first and third is 8. Sum, remember, keyword for plus. So x for the first, z for the third. Sum of those is 8. Now we have a system of 3 equations. So check yours out, see if you had something similar. All right. Now let's look to solve this one. If we solve it, this looks like one where we could solve by substitution. And the reason we can solve by substitution, looks like we got one right here that has like a y equals. That's telling us probably substitution would be a good call here. So if we substitute, the bottom equation doesn't have a y, but this top one does. Let's plug that in right there. So that equation now becomes x plus 4x plus z equals 20. And these two would be like terms. If we combine those together now, what we have is 5x plus z equals 20. And we made that substitution. We still have this last equation, that's x plus z equals 8. Now we've turned our problem into 2 equations with 2 variables. We've gotten rid of the y. So now this is like we did yesterday. Again, solve this out, and we should be able to come up to the answer. This would be one we can multiply by -5 to the bottom or -1 to either, and we should get it. I'm going to multiply the bottom by -1. So if we do that, our bottom equation will become this. Adding these up now, we got 4x, the z's eliminate. Divide by 4, and looks like x is 3. So the first number is 3. We could substitute that back in here easily now and find x, or sorry, find z. So you got 3 plus z equals 8. So it looks like z is 5. Okay, now we got to substitute back in and find y. Probably the easiest place would again be to substitute x into this y equals equation right here. Y equals 4 times 3. And y equals 12. So it looks like the first number is 3, the second number is 12, the third number was 5. Okay, so substitution ones usually are quite a bit easier than the elimination ones. All right, the next one, another word problem. It says there's 49,000 seats in a sports arena or stadium. The tickets for the seats in the upper level sell for $25. The ones in the middle level cost $30, and the ones on the bottom are $35 each. The number of seats in the middle and bottom together equal the number of seats in the upper level. When all the seats are sold for the event, the total revenue is shown. How many seats are there in each level? Okay, so now we want to come up with an equation again. Pick some variables that are going to help you. If you want to use x, y, and z again, go for it. I'm going to use ones that are going to help me a little bit more. I'm going to use u for upper, m for middle, and b for bottom, just so we kind of know what it is. Okay, so it says there's a total of 49,000 seats. So that means if we add together the upper level plus the middle level plus the bottom level, it should total 49,000. They tell us the prices of each of these. We got a price, a price, a price. We need a total that is also talking about money that we can put that equal to, and we have one down here. So if we have 25 for the upper plus 30 times the number of middle seats plus $35 times the number of bottom seats. All that money should total up to be that number. All right, we still need one more equation though, because we have three variables, which means that we need three equations to solve. We do have this middle sentence here that can help us out. It says the number of seats in the middle and bottom together equals the number of seats in the upper. So if we add up the middle and the bottom, it should equal the upper level. So now we got three equations, three variables we want to solve. This looks like another one here, this last equation, where you know what the upper level equals, we could do some substitution. So let's substitute in m plus b anywhere we see a u. So for there and here. And now we can get our equations just down to m and b. So if we do that, we get m plus b plus another m plus b equals 49,000. If we substitute it into the second equation, we got 25 times m plus b. Okay, now what you want to do before you start doing any more elimination would be to simplify these two equations, because you can see there's some like terms here that we need to do. There's some distributing that we need to do and probably some combining there. So simplify these out. So the top equation is going to end up being 2m plus 2b equals 49,000. The bottom equation you want to distribute, so it'd be 25m and 25b. If you add those with those other m's and b's, you're going to end up with 55m plus 25 and 35 is going to be 60b equals this dollar amount. Now this becomes an elimination one like we did yesterday. Figure out something you can multiply by to do this. Looks like maybe we can multiply the top one by a negative 30 and our b should eliminate there. So if we multiply it through by negative 30, that's going to be negative. And if we add that now with our bottom one, our b's eliminate. And we'd end up with negative 5m equaling, this would be where you'd want to probably use some type of calculator to figure this one out. We can type that in. And we should get this number, so we know the negative 5m equals this. So now if we divide by 5, we should get that. And dividing by a negative 5 makes this positive, so we'd have, looks like 10,100 seats in the middle level. Now it's just a matter of going and plugging those back in. A good place to plug those back in would probably be like right here would be a good place to substitute it for m. And then once you find b, then you can substitute it in back up into one of the original equations, probably this one being the easiest to find u. Okay, I'm not going to go through the rest of that. If you want to go through and find that, you can. It should come out that the bottom level ends up being 14,400 and the upper level ends up being 24,500. All right. One more problem on your note sheet. This one says, Mike knows that he has scored a total of 70 points so far this basketball season. His coach told him that he has scored 37 times, but Mike wants to know how many free throws, field goals, and three-pointers he has made. The sum of his field goals and three-pointers equal twice the number of free throws minus 2. How many free throws, field goals, and three-pointers has he made? All right, so again, we know a total. He scored 37 times. So if we add together his total baskets, he should get that. There's three types that they tell you. X we'll use for free throws. That was one type. Let's use Y for field goals. If you want to use something else, you definitely can. And Z for three-pointers. Now, you got to know a little something about basketball to do this problem. Most of you probably could guess three-pointers are worth a total of 3 points. If you've watched basketball before, other baskets are worth 2, and free throws are worth 1. So we got to kind of keep that in mind as we're doing the problem. So if we add together all types of baskets, they told us that he has made 37 types of baskets. His point total, we got another total here, is 70. If we're going to talk about points, now we need to add the point values in with each one. So we got one, each free throw is worth 1, each field goal is 2, three-pointers are worth 3, and if we multiply that to each type of basket made, it would be 70 points. But we're one equation short here. We still need one more. I think we got one more thing we could figure out with this one. It says the sum of the field goals and three-pointers equals twice the number of free throws minus 2. So let's go through and see if we can do that. Field goals is Y. Remember, that's our plus one. So plus three-pointers, we're using Z for three-pointers, equals twice, 2 times, the number of free throws minus 2. So the free throws we're using X minus 2. Now we got 3 equations, 3 unknowns. This is one we want to try to solve out now. So looking at the problems here, this one doesn't look like we have a substitution one. So it looks like we're going to have to use the elimination one. Now if you look back at the elimination ones we did before, all the variables were lined up. X's, Y's, Z's, and constants were all kind of lined up. We don't have that right now on this problem. So our first step, we want to try to stay organized because these are tough problems. Let's try to get all the X's, Y's, and Z's and constants lined up. The first 2 equations are fine. Let's change this third one a little bit so it fits our needs. So let's minus 2x over to the other side. And then I think we have it. Okay, so it would end up being minus 2x plus y plus z equals negative 2. Okay, now we got to pick a variable to eliminate. And on this one, you could really pick any of them, and it would be easy to do. I'm just going to go with the very first one, x. Let's try to make those all the same number. And it looks like we could do that by multiplying both the top and middle one by 2. That way they're all 2's and one of them's a negative. The last one's a negative there. So if we multiply everything on the first 2 by 2, we get, oh, forgot to multiply the constant term. Don't forget to do that. That would end up being 74. On the next one, you get 140 multiplying the constant term. And the last one we said we're not going to do anything with because we like that negative 2 there to eliminate. Okay, now we got to add. Looks like on this one we'd want to add the first and last equations together. That would eliminate the x's. Also, if we added the middle and last one, x's would also eliminate. So let's do that elimination and see what we get. So adding the first and last one, we get 3y plus 3z. Adding the constant terms equals 72. If we multiply or add together the bottom and middle one, x's again eliminate, you get 5y plus 7z. equals 138. Now you're down to two variables with two equations. Now you'd have to figure out something to multiply it by here to get elimination. Not anything really easy that jumps out, so this would be one you'd have to multiply both. Let's eliminate y's here. If we multiply the top by, say, -5 and the bottom by 3, we could eliminate that. So now our equations become -15y minus 15z equals -360. And if we multiply the bottom by 3, we get 15y equals 414. And now if we add those up, they eliminate the y's. We get 6z equals 54. And dividing through, looks like z is 9. So you made 9 3-pointers. Now it's a matter of, again, going back and substituting back in. And I'll let you try that on your own if you want, because you should know how to do that by now. If you keep doing it, ends up that y, or the number of field goals, is 15, and x, the number of free throws, is 13. All right. Try some of these out on your practice sheet.